Hello and welcome. Today we are going to continue looking at energy changes in chemical and physical processes. In our previous video, we talked about endothermic reactions. We talked about exothermic reactions. Now today we are going to see how the presence of a catalyst usually influences the rate of a reaction. Now, the rate of a reaction is how fast or how slow reactants are converted into product. Now, for this reaction here, what we say is that we have potential energy that is stored in these bonds. Now, we have a bond between nitrogen and nitrogen, and a bond between covalent bond between oxygen and oxygen. So we have our covalent. Now, in these bonds here, we have energy that is stored here. Now, for chemical reaction to take place, we have, now remember this reaction is between nitrogen, oxygen to produce nitric oxide, nitrogen 2 oxide. For a reaction to take place, you need first of all to break these bonds here. So that now we have individual atoms, like you have 2 nitrogen atoms and 2 oxygen atoms which are separate because this bond has been broken. Now to break this bond here, you need to supply energy. And that energy is what we call activation energy. As you can see, this is a symbol for activation energy. And the work for this activation energy is to give these two molecules here some energy. Now we call it kinetic energy. And kinetic energy is the energy that is possessed by atoms that are, or substances that are in motion. Now these molecules here, once we supply energy, they have what we call now kinetic energy. And in this case, as they now are able to, if they're in motion, they are going to collide with each other. And they are going to, once they collide with each other with the required impact, they are going now to break into those individual atoms like that. The bonds have been broken. Now, these broken bonds here, the next point which is going to happen is that new bonds are going to be formed, like this. Now we have a bond between nitrogen and oxygen to form nitric oxide. And another bond formed like that. So we have 2 molecules. As you can see here, we have 2 molecules over. So these are totally new products which have been formed like that. Now, this path that has been followed from the reactants to the products, this is what we call a reaction path. And this path has been followed when we have not added any catalyst. Now, when we add catalyst, what usually happens, this path, we change the path such that now we form the products more easily. So instead of this transition, this is also called a transition peak. Instead of that peak coming there, what usually happens, you are going to supply activation energy. There will be kinetic energy, and these molecules are going to collide. And when they reach here, now this bond will break. So they will break at a much lower activation energy, and then new bonds are formed quite quickly, as you can see, like that. So at the end of the day, we have shortened the route that is taken, or the reaction path has been shortened, and that means we have reduced the amount of activation energy like that. So you see, this is our new activation energy. So, and the reaction has taken quite a shorter route, so the products have been formed quite fast. So the work of a catalyst in a reaction is to make sure that we change the path to quite a shorter path, so that the reaction takes place quite fast. That means the products are formed very fast from the reactants, and so the amount of activation energy or energy now that is supplied is quite easier. Now the advantage of this is that now if you are supplying this activation energy or heat or anything from maybe electricity, we are going to use less electricity, then we are going to save money. Remember, a catalyst can also be recycled. When in a reaction like this, a catalyst is not used up, so we can do so many reactions using the same catalyst, and in that case we save money. So in conclusion, as you can see here, we have two parts to come to form these products here from our reactants here. So what usually happens, this part is quite wrong. You need quite a lot of energy. You can see the activation energy for this. This part is quite high. But now, when you apply now a catalyst, what usually happens, the activation energy now becomes less, and we follow this path here. We reach into our products quite easily, so the rate of reaction is faster. Thank you very much for watching this video. We meet in the next video where we shall discuss the effects of temperature on our rate of reaction. Bye and subscribe.